So in the previous class, we have seen the calculation of the force between any two charges, and if there are n point charges, how to calculate the force acting on one charge due to the presence of n charges. Now let us solve a problem. In this problem, there are 3 point charges of 1 millicoulomb, minus 2 millicoulombs and 10 nanocoulombs, and each of these 3 charges are placed in 3 different locations as shown in the problem, as shown in this figure. And you need to calculate the force that is acting on the third charge, which is 10 nanocoulombs, which is located at a certain point of interest 0, 3, 1. Okay, let us see how to calculate the force. The point here, we need to understand one thing, where we have to take your point of interest, which one is point of interest and which one is point of source. Wherever we need to calculate the field or force, whatever it is, that point is considered to be point of interest, and the other charges which are placed at different locations, those are point of sources. Okay, if you know this thing, then it will be easy for our distance vector calculations. Okay, so according to this problem, I am taking 3 different point charges which are placed at 1 millicoulombs and minus 2 millicoulombs are placed at the different locations 3, 2, minus 1 and minus 1, minus 1, 4. And the third charge is 10 nanocoulombs, which is placed at 0, 3, 1. So this is your point of interest, and this two are point of sources, point of source 1, point of source 2. Okay, so we need to calculate what is F at this point of interest due to the presence of these two charges. So let us write the formula to calculate the force using the Coulomb's law. F is equal to, using the superposition theorem, it is 1 by 4 pi epsilon naught, where epsilon naught is the dielectric permittivity of the free space, which is measured in farad per meter. Okay, 1 by 4 pi epsilon naught. The point of interest charge is considered as Q. This is considered as Q1 and this is considered as Q2. So it is Q times of first charge Q1, the distance vector, let us say R1 by magnitude of R1 cube, plus second charge Q2, the distance vector R2 by the magnitude of R2. This is the formula. Now, what are the distances between the first charge and the point of interest? This is our distance R1 and point of interest, and this is second source. So this is R2. Always the force is acting on the point of interest due to the source. Okay, so your force is directed from the source, force vector is directed from the source towards the point of interest, and hence this is in this direction. Okay, so R1 also, unit vector also is directed in this direction. In the same way, the force due to Q2 on the point of interest is acting in this direction. So your R2 vector is considered to be in this direction. Okay, so if this is the direction of the vector, then how to calculate the distance between these 2 points? This is x1, this is x2, so it is x2 minus x1. Okay, that means POI minus POS always. Okay, so now here we need to calculate the distance vectors R1 and R2. In order to calculate R1, we need to note down point of interest and point of source. Point of interest is at 0, 3, 1. Point of source is at 3, 2, minus 1. Hence, the vector is 0, minus 3 AX along x direction, 3 minus 2, which is nothing but along y direction 1 AY. 1 minus of minus 1 is 2 along z direction, so plus 2az. Now what is its magnitude? This is the distance vector and the magnitude of R1 is nothing but under root of minus 3 whole square plus 1 square plus 2 square, which is nothing but 9 plus 1 plus 4, which is 14. In the same way, similarly, we can write the distance vector R2, which is again POI minus POS2. Now this is second charge. So POI minus POS, again we have to write the points for our simplicity. Minus 1 comma minus 1 comma 4. Okay, so if you note down this, then we can write easily the distance vector as 0 minus of minus 1 is plus 1, so along x it is 1ax. Along y, 3 minus of minus 1, which is 3 plus 1, 4. Along y direction it is 4 units, and 1 minus 4, which is minus 3 along z. This is the distance vector, and what is the magnitude of this? It is nothing but under root of 1 square plus 4 square plus minus 3 whole square, which is again 3 plus 1 is 4, 1 minus 4 is minus 3. Okay, so it is 9 plus 1, 10, 10 plus 16, which is 20, root 26. Knowing the distance vectors and knowing the charges, we can easily substitute, and also knowing the form epsilon naught value, we will just write down the simplified form of 1 by 4 pi epsilon naught value here. Okay, and also we know what is Q, 10 nanocoulombs. Let us write this, solve this coefficient here. Q by 4 pi epsilon naught is nothing but 10 nanocoulombs by 4 pi times of the formula for epsilon naught is, the value of epsilon naught is 1 by 36 pi into 10 power minus 9. Okay, so it is 9 times, and hence it is 10 nano into, this is 9, 10 power minus 9 becomes 10 power 9. So 10 power 9 and nano gets cancelled, you will get 90 as the coefficient here. This term Q by 4 pi epsilon naught is 90. Let us write it here. Now we will solve this internal brackets and then write the final answer. So the first one is Q1. Q1 is 1 millicoulombs. Okay, 1 milli into the distance vector R1, which is minus 3ax plus ay plus 2az divided by magnitude whole cube. The magnitude is 14, root 14, whole cube is, root 14 is, I can write 3 by 2. Okay, then plus or minus Q2 is actually minus 2 coulombs. So I am writing minus 2 milli into the distance vector R2, which is ax plus 4ay minus 3az by magnitude is under root 26, this whole cube, which becomes 26 whole power 3 by 2. Okay, if we need to simplify, using the calci, you get the magnitude, the value of this, and then inverse it. If you do the inverse and then multiply with the respective coefficients, this is the simplified one. And in the same way, okay, you have, okay, now this is correct. Okay, then again you simplify this term and you multiply with the coefficients that are here. Then you can simplify the entire two expressions by adding the like components, which is nothing but ax component, ay component and az components. You have to multiply with 1 milli here and 2 milli here. Okay, if you do this simplification, I am taking milli as I multiply outside, there is 90, q by 4 pi epsilon naught, there is 90, right? So if I multiply entire value of this with 90, I get this kind of expression. Then after simplifying by multiplying 0.09 inside, I get this value. So after multiplying 0.09 with this, I get each individual component coefficients as this into milli. Okay, so the units of force, the final answer after simplifying this is this much millinewtons. The force units are newtons. So this is how we calculate the force between a force that is acting on the given point of interest, the charge that is placed on given point of interest due to the charges that are present at different locations. Thank you.